But before we go right into it, let me introduce you myself. I'm Marco. I'm part of a team of surveyors with 20 plus years of experience in traditional surveying. In 2011, we start actually with drone surveying. We finished more than 500 successfully completed projects just based on drone technology. And today, 3D survey software is present globally. Everything we do is based on solving actual daily challenges surveyors faced all over the world. And we believe that when it comes to productivity, we are the same as any other human being. We all want to do more with less effort, right? That's exactly why we invested over 20 years of experience to create this 3D survey solution that will help make your jobs and life a little easier. Worldwide, you have a great support network of more than 35 distributors, which are all well-trained 3D surveyors and can offer you an instant support in any project. And this brings us to today's plan. So we will be comparing 3D surveying to traditional methods, especially in terms in productivity, time, cost, accessibility. We will show you how easy it is to work with 3D survey, how you can become an expert 3D surveyor and cut fieldwork time up to 10 times. And make sure you stick around because we have a little surprise for you. We will tell you everything at the end of this webinar, I promise you. So we are going to take you through it step by step and talk about how we capture data in comparison to traditional surveying using drone technology. We will see just how accessible and easy to use it actually is. How we process the data up to 15 times faster than anything you've seen before. And finally, how easy it is to export your work, basically any third-party software, and share it with your colleagues. If you have any questions as we go along, just type them. My colleague Vit is here with me and will help me to answer your questions right away. We all know that traditional surveying is time-consuming in most of the cases. Surveying gear like total stations and GNSS instruments are very expensive. Sometimes we have to measure really difficult and dangerous terrain like open pit mines, garbage dams and similar terrains, and in case we forgot something to measure on a field, we need to return back. Measure once again, and this costs additional time and money. Drone technology is now fully commercial, which means you can get really good equipment without hurting your wallet. Technology is now available for every surveying company. Most popular drone like Phantom 4 Pro costs just 1,500 euros and you can buy it in almost any store or via Amazon. They are super easy to operate. From unboxing to flight you need less than a half an hour. And computer vision algorithms are now so powerful that you can achieve centimeter grade accuracy, which shows you the realistic terrain much more visual. So no more field revisits. And here is just a quick overview about the drone solution for 3D surveying. I would just like to mention that here definitely dominates the market Phantom 4 Pro and now also Phantom 4 RTK. It is the most user-friendly drone on the market, which we can say it's industrial produce. It's small, reliable, easy to use and costs just 1,500 euros. Has an integrated camera, which because of global shutter works really perfectly in surveying project. Then in the next group, you can see drones assembled from parts. They are more expensive and more complicated to use. We would suggest them for some specific applications as inspection with a thermal camera and so on. In last column, we can see fixed wings. They are perfectly for surveying the large area but need a lot of space to start and land because they don't have a vertical takeoff and landing. This was also a quick overview about the available options. If you like to know more, write us in the chat checkbox, and we can share with you link with a more detailed presentation where you can see even more about the drones which are currently available on the market. Now, I'm not really sure how many of you have ever flew a drone, so maybe tell us in your checkbox that we can have a feeling, because I'm sure some of you might be curious about what it's actually like to fly a surveying drone, alright? Well, let me tell you right away, it's super easy, especially if you have a cool piloting app, and since we developed one, I'd like to show you how really easy it is. Okay, so let's play the video in a short presentation, and here we can see the short video about workflow for data capturing. First, we plan a mission. We have 4 different types available, so grid, polygon, road and circle. Simply select your area of interest, set the correct parameters, and when you are ready to go, just click on a start button on automatic start. The 3D Survey Pilot is now available for Android on Google Play Store and in iOS Store. So feel free to download them and use it for your daily task. So we can see in the video, during the flight, we get our telemetry data from drone, camera from drone, so we have a realistic image, and after 50 minutes we land with drone and we are already finished with the terrain. Okay, and this brings us already to our second step, so processing part. This is also the core part we are working on the most of the time. Before, let's say around 2011, the problem was that the technology was not available or was extremely expensive. Our first drone cost us 40,000 euros, and at that time there was no software to process aerial images to get the results. This is also the reason why we started developing this solution. Now you have a tailored solution available, which was designed by surveyors for surveyors. It's a super user-friendly and has a really short learning curve. All the results you can easily export and are compatible with most standard CAD or GIS softwares, and works on most home office computers that run AutoCAD and similar softwares. And yes, whenever we talk about photogrammetry and drone surveying, people always ask us about LiDAR, and this is how usually we respond. So yes, it is a good alternative, but you have to consider with additional cost, heavy equipment, task-specific projects. In any case, it depends on what you're trying to survey, but even if you decide to go with LiDAR, as far as your hardware needs are concerned, 3D Survey is fully compatible with it. In case there are some questions, once again, feel free to write them in checkbox on your right side, and my colleague Wit will try to answer them parallel. Okay. Now let's see a short video what kind of result you can achieve with 3D survey technology. Here we can see dense point cloud with realistic colors, because these points were calculated purely from images. You have availability to use advanced algorithms. Here is one of them, automatic classification, which recognize the terrain points, and in this way we can eliminate high vegetation, building, machinery, cars and similar objects in no time and calculate accurate digital terrain model. You have option to select different view styles. Here we can see hide map view. With one click you can calculate detailed contour lines and export them in DXF for any CAD software. In case you would like to calculate volume of specific pile, just select your area of interest and click calculate volume. Another really interesting feature is profile lines, calculation and automatic production of reports, or just easily export them as graphs in a DXF and import them in AutoCAD or similar CAD software. So this was just a short introduction what actually 3D surveying is possible. Let's go to our next slide. And we are already at software presentation. So this was just a short video presentation. Now we will go and see how powerful 3D surveying is on a real project. We will quickly check the basic workflow. Then I will show you top features which are integrated in the software and what are export options. If there will be any question, once again, please feel free to write them in chat box and we will try to answer them as soon as possible. Okay, so let's turn on our software. So when you start a 3D survey, this is the welcome screen. What you can do here, you can start here with new project or open existing one. So I already prepared one project that we can go step by step and show you how it actually works. Here we have already imported images, so you can see the image list on the right side. You see totally 602 images, so this is already quite a big data set. And the total area size is around 500 per 700 meters. So some kind of typical surveying projects. So if I move between the images, you see we have a great overlap. This project was done actually with the Phantom 4 Pro. So this is kind of a bestseller in drone area right now. And after we import the images, we also import the position of cameras. So those are those blue triangles. And then on the right side, we have three main steps. So the first one is bundle adjustment. This one step takes approximately 20 minutes for 600 images on average computer. After the bundle adjustment, we get the results, so-called sparse point cloud. So we already see some 3D points from the terrain. We can get some estimation how it looks like. And we are ready for our second step for orientation with GCP, because we don't want to lose too much time on this. This project is already orientated. You can see those 6 green points from P1 to P6. These were our orientation points, and we check here the orientation accuracy. After we finish the orientation, the accuracy is around 1 centimeter. So pretty precise example. Usually this should be up to 4 centimeters, so surveying grade accuracy. Okay, then after the orientation, we are ready for next step, dense reconstruction. Here we can set the reconstruction level. So most of the cases users are selecting high level, and this takes approximately 5 to 10 hours for such a big project. If you have small one, you can calculate it in 1 hour. Okay, I will skip this now and show you the result of reconstruction. If I go to point cloud tab, you can see it right here. Okay, so we have about 29 million of points which describe realistic terrain. Up there you can still see the camera positions of the drone during the triggering. We have a 70% of the vertical and horizontal overlap, so every detail on this point cloud is at least on 10 images. Let's turn off now the camera positions and inspect this point cloud a bit. So as you can see, it's pretty detailed with a lot of information. So you can see, you can define also what kind of material, for example, you have in some specific part here. Okay, then from this point cloud, users usually go and classify the point cloud so that they get just terrain points to eliminate. So all artificial objects like cars, vegetation, houses, and all this machinery which is needed for such an area. And then based on this, they go and calculate DSM. Here is already recalculated, and we can see it here how it looks like. So pretty detailed, everything really nicely described. And let's focus maybe on this part. So we have also different view styles available. If I click hide map and show grid, I can maybe even better see the heights, how it's changing about this stockpile. And now what I can do, just use our selection tool, select my area of interest, it's colored red, and then calculate volume from current selection, and in a few seconds we will have the volume of selected material. So as you can see, pretty easy. Select your area, calculate volume. Now we are comparing upper and lower surface. Lower surface is now generated based on round points. In case you have two measurements, so one mount first measurements, next mount another measurement, of course you can compare this volume. Okay, here we can see the results already, 4,243 meters, cubic meters, so quite a lot of material. Let's say material 1 and save this result. And as I already explained, just for your feeling, this is area 500 per 700 meters. We need a single battery flight for this, so it took us approximately 15 to 20 minutes with drone. We need additional half an hour to measure those ground control points, and we finish with the terrain. So around 1 hour and everything is measured outside in the terrain. Imagine to do this, to measure this with the traditional technology, you would need at least 1 day to measure this field, and of course at the end with traditional technology you would get approximately 500 points with GPS or total station, and then based on this you would do all the calculations. But here you get 30 million of points, you can easily select anything you would like to have. Okay, cool. Let's have a look about this volume in a 3D. So first, if I go to orthophoto, I also see my selected material on orthophoto. Why I'm showing this, you have really quick exports available in PDF, JPEG or anything like that. And then if I go a bit right here on my side, you can once again see just the volume upper and lower surface, and once again on the right side results. There are a lot more options with the volume calculation available, so you can calculate volume based on DXF boundaries or anything like that. So most of the cases are covered, and I must say that if you need to calculate volumes or something like that, there is no better technology currently available. You are at least 10 times faster comparison to any traditional technology, even with the LiDAR instruments. Okay, comparison with the LiDAR instruments. Okay, second top feature, which are definitely also profile lines. So here are some parameters. We will do the transverse profile lines calculation, and I will just set, let's calculate every 5 meters, 30 meters left and right our profile lines, and I will once again select the same area. And we can see the software will calculate 11 profile lines. We can see those red lines already in a point cloud step, how they goes. Then you can see this in a DSM model. You can see calculated profile lines here in a orthophoto view, and of course as a graphs. So this is our longitudinal profile line. Let's just take the text a bit smaller, so to 50. Just a second. Okay, profile title also. So you have quick option to set the values, and here we see our longitudinal profile line and then cross sections every 5 meters. And what is really interesting here, just go export this to DXF, and you can import in any CAD software as AutoCAD or something like that. So all data types are fully compatible with third-party softwares. Okay, we finished now with one example of profile lines and orthophoto calculation. Now I would like to show you how easy to generate report. So let's say test 1, and we will include volume calculation and my profile lines. Here we have more cross sections. Let's create a report. This takes a couple of seconds. And here we have our doc file. So we see all the important information with which version was calculated. Here we can see once again the fill, cut and netto value, 2D area, 3D area, lowest, highest points. Here is our selection where the volume was calculated, and then the second important things, profile lines, most important points here, and of course every 5 meter cross sections or cross section or transverse profile lines. So as you can see, pretty easy, one click away, and super user friendly to use this software. Of course, those were just two of the functions. Then based on DSM, we can really quickly can calculate also control lines. So you can see them here. Actually, pretty detailed every meter. So this is just one click away. Once again, you can export them in 2D or 3D. We will do this a bit later. Okay, cool. I will finish now with the software presentation here, and we will continue with our presentation right here. Okay, and we are already at our last step, how share the results with your customers, let's say construction companies or government representatives. First option is to export point cloud. So let's go to point cloud and have a quick view. So point cloud save as, and here you can see number of file formats. The most popular is definitely PL epsilon or maybe LAS file, which is most compatible with any third-party softwares. Then if we move further to DSM, you can go to DSM save as, and here you can see once again a lot of standard file formats. Maybe the GeoTIFF is the most popular. You can easily import in any CAD software like AutoCAD with no problem. Then orthophoto, once again orthophoto save as, and you can also define number of options. Definitely the most popular is GeoTIFF, which has already written coordinates of the corners inside, just map insert function in AutoCAD map or anything like that, and the orthophoto will place on the correct place. Now what I would like to show you is KMZ file format. So let's say Google Earth file. I will just set here to 10 centimeter resolution orthophoto, so not to wait too long. I think the basic resolution of this project is 2 centimeters. This is also the average resolution for most projects, where you can see enough of details so you can draw later on any CID lines or anything like that. Okay, here's already generated file. So what I'm going to do, double mouse click, and it should immediately be opened in a Google Earth. Okay, here we can see our own calculated orthophoto comparison to Google Earth. Maybe I will just turn off 3D buildings to see better presentation. And you see, because we have all the coordinate systems, everything it's nicely placed on the right position, and you can in this way easily share orthophoto results with any of your customers. Okay, let's close Google Earth down and go back to our software. And here we have also CAD tab, where you can actually create some basic CAD lines and so on. We have on the right side already few layers on. As you can see, those were actually boundaries for volume calculation. You can easily save them also as a DXF file format or XML KML shapefile. So select any one of them and export them out. What I would like to show you now is how easy it's actually to export contour lines and import them in AutoCAD. So let's save it in a DXF file, contour lines. Okay. just double mouse click on. I actually don't have an AutoCAD installed on my laptop computer, so I'm using the TrueView from AutoCAD. It's a free version for viewing the DXF files. Let's just wait to open it. Okay, just zoom extend function, and here you can see actually our contour lines. Everything is done with the correct layers, so you have main contour lines, semi-main contour lines, and of course, because we export it in 3D, everything is actually also in 3D in AutoCAD. So you can see it's fully compatible. One click to export the data. The same way goes with the profile lines, with the orthophotos, with or anything like that. Okay, great. So let's close our TrueViewer. And another option to share your results is with our 3D survey viewer. The idea is that in case your customer, let's say construction company or government representative, does not have powerful software for viewing the 3D data, he simply download our free viewer from web page and easily import your project and inspect the data. He has a possibility of the basic features which we have already seen. So let's have a quick view how this actually works. So here we have already opened 3D survey viewer. As already said, you can download it for free from our 3D survey webpage, and then you share the project with you. What you save in the project he can actually observe. I will now browse to my project file. So here it is. Just double mouse click. Let's wait a couple of seconds to load the project. Okay, we can see already here the entire project, the same one we have in our 3D survey software before. I will now just turn off cameras, ground control points, sparse point cloud, also maybe DSM model, volume calculation off, and close my 3D view. Once again, double mouse click just to fly through to our area of interest. The same option as in 3D survey. You can increase the diameter of points to see better. Okay, and if I focus on this part, two options are available. By default, here is investigation on coordinates. On the lower right coordinate, on lower right corner, you can see the 3D coordinates or any specific point. And then the second option is measurement tool, so you can easily measure any detail in a field. So because it's in a 3D, you can see all the 3D dimensional data, right click on measurements, and you can deselect what you want like to see. So in this case, I'm just looking for 3D distance. Now we are in 3D view. If I click on my orthophoto image here, I'm in 2D view. And for example, then I can do the measurements in 2D. So let's measure, for example, our area of interest. If you close the polygon and finish with right mouse click, you also see in square meters how big the area actually is. Okay, let's go back to 3D view. Here's also another interesting thing. So we save the volume measurement. That's why we see here the volume of material. Let's turn off the DSM, and we can see here our volume was measured in 3D survey software, and your construction company can easily see all the important values there. Okay, this was just short introduction about our viewer. Another option to share our results or to share your results with your customers. So it's pretty simple, pretty easy. If they don't have a powerful 3D software, they can get it for free from our site. Okay, let's move to our next slide. So how does all this benefit for your business? In this slide, we can see direct comparison and the benefits of the 3D surveying technology compared to traditional surveying techniques. So definitely, as we already saw, if we have some project with volume calculations, we can easily say we are 10 times faster than comparison to traditional technology. The results are much more accurate and much more detailed. So it's just not possible to measure the same terrain with traditional technology just with 200 or 300 points, and this compare it with the 3D surveying technology where you have any detail there, and you can later on in an office inspect anytime any data you would like to get. Then second project, we can say road measurements or survey map. It's kind of connected a bit. Once again, when you do the flight, you get the complete information. End results is orthophoto map, so any detail you would like to have it, you can have on map. So no more field revisit, no more returnings. Sometimes happen, you measure with traditional technology a house and let's say 100 meters around your house, but then your constructor or anyone would like to have additional a bit more, you need to go back, measure it additionally. This will never again happen with this technology. And we did a test comparison for the road measurement of 1 kilometer. Because you have complete data, you are 3 to 5 times faster in any case with these measurements, even if you combine it with a bit of traditional technology. So in case you measure the corners of building with the total station, even in this case you are much faster. And nevertheless, end result is also orthophoto map. They always like to zoom in, check a bit, there's more detail on it comparison to just traditional vector data where you get just points, lines and areas. So when you come back to the office, you know you always need to remember what did you actually measure. You need to create sketch on field, which is really difficult, really hard. Even if you measure with codes, it's quite hard to get it. Okay. So in this case, as you can see with the photogrammetry, you can easily manage to finish most of the project on a field in less than 2 hours. So as you've seen, the technology is really amazing, wonderful, ready for daily use. Because it was developed based on field experience by surveyors for surveyors, it's extremely user-friendly. And we finally reach the most important part of this webinar, so how you can become an expert 3D surveyors in just 6 hours. And we are proud to be able to provide you with all-in-one solution for this. So you have a 3D survey pilot, you have a 3D survey software, and you have a 3D survey viewer where you can share the data. So it's a full package deal, lifetime value. We have regular software upgrades and actually fee requirements. So we ask our customers how much time do they need, and briefly we can say like, so you need in 1 hour to purchase the software and drone. You need 2 hours of drone training to be confident to fly by your own. Most of the things it's actually happen automatically. And then you have one-on-one training for the 3D survey software. This takes around 3 hours. So we can say in around 6 hours, you are confident to go out, measure field and work on your projects. And then of course, the best customer support ever is included in a first year and so on. If we have a quick look about the cost of traditional surveying equipment, we all know the total station and GPS instruments cost at least 30,000 euros or more. So it's pretty expensive comparison to 3D surveying technology, where the complete package price is less than 5,000 euros. In this package, you will get drone, 3D survey software, and of course, one-on-one training. And you can start working on project independently the next day. Just for example, if you finish just 2 bigger projects, the return of investment is already there. You don't have to jump right into it. The most important thing is that you see if this makes sense for you and your business. That's why we have a free 14 days trial available with unlimited functionalities, and remember, we said you can learn it in hours. You can try processing your own data, of course. You get also specific data set if you still don't have a drone, so feel free to go. Don't forget that you have available our top support. If you will need some help even during the trial period, feel free to send us email on support@3dsurvey.si or contact us via phone, Skype or WhatsApp. We present globally, so you can also contact our distributor in your country. On our webpage, under contact, you can find the most important information. Even in the sense of free digital content, we're also doing some more advanced webinars on specific field cases and projects, so make sure to keep an eye out for future content, by the way. And yes, we promise you a little surprise at the beginning. We'll be selecting some of you and gift you with free exclusive personal support for a personalized demo experience. We will keep in touch via email. All you need to do is just to download the free trial and we'll keep in touch. Okay, this was all from my side today, and thank you for visiting the webinar.
Okay, thank you, Marco. So this was the first part of the presentation. Now for the second part. If there are any questions, please write them into the chat section. So we haven't had any of these yet. For now, let me switch to my computer. So if there are any questions, please feel free to ask them. Otherwise, I have here also a small example of a dataset created in 3D Survey. So here you may see that we have here some 3D lines. So, and the point cloud and VSM. Let's drape an orthophoto onto the digital terrain model to make the dataset a little more representative. So we talked a lot about the accuracy of this kind of data. So here in this example, the lines were actually measured with the total station. So, and here we can see pretty well what kind of accuracy we can expect from this data type. So the line points are where the surveying team went and measured points. And this was an actual project that Geo2 company was doing. So we can see their car here in the 3D model. And basically what we can see is that we can really get the centimeter grade accuracy from the drone data. We know that that might sound a little bit unbelievable, but when we compare two independent measuring techniques, the results are there. So even if we try to measure height difference between a point, so let's set it here. Let's see what's the height difference between where this point was measured with the total station. And so now these are the points on the point cloud. And we see here on this asphalt area, we get maybe centimeter, 2 centimeter, 3 centimeter difference from the points on the point cloud to the 3D line measured with the total station. So this is a pretty good accuracy, and this is what can be achieved. So we can use this technology to speed up our production of survey maps. So let's go back to our presentation and see if we have some questions in the chat section of this demonstration. So I see we don't have any questions for us. So In this case, if there are no questions, I would like to thank you for watching this presentation and come back also next week when we will be doing additional advanced webinars. The next week, the first thing we will be presenting will be the new features coming to 3D Survey. It will be pretty interesting because we are now in the developing a pretty big update, which will make this technology even more attractive. But not to say too much, I would just like to thank you once again and wish you a pleasant rest of the day. Bye bye and happy 3D surveying.